Go ahead, take it away.
No, you cannot, but at least you can see the slides. OK, so hello, everybody. Thank you for being here. I guess that if we are all here attending the last session of ICFP, it's because we have something in common, some interest in common. And this interest is that we love functional programming. But what is it about exactly? Is it really only about function? And actually, maybe not. Maybe we have something more deeper. Maybe what we really like is dealing with code, that is, reasoning about code. And for that, what do we need? What are the properties that are needed? We need determinism, because if you don't have determinism, you have to understand your program in the execution context, or in the current execution context, which is much harder. And we need composition, because if you don't have composition, then you have to reason about your program as a whole. You cannot decompose your reasoning. So these are two fundamental properties that we need for reasoning about programs. And the point we are trying to make in the paper is that for that, you don't only or you don't uniquely need functions. And for making the demonstration, we are using an application domain, which is the solving of Sudoku. So what do we do with Sudoku? Well, actually, solving a Sudoku is already a solved problem. You just transform your Sudoku puzzle into a set of constraints, you fit that to your constraint solver, you hit the return button, and you get the solution. So this is not exactly what we are doing. What we are doing is trying to evaluate how hard or how difficult is a Sudoku problem. This is slightly different. What are we referring to? Well, actually, this is a screenshot of a website that is just a repository of Sudoku puzzle. You know, Sudoku is a kind of a parallel universe with its own language, its own website. It's just crazy. This is one of them. And you see here that on this website, they are using a classification where they have easy puzzle until diabolic puzzle. What does it refer to? Let's go to another website, which is just a repository of heuristics that you can use for solving Sudokus. And if my recollection is correct, in this website, they have something like 180 different heuristics you may use. Let's just check a few of them if you are not so familiar with Sudoku puzzle. So the first strategy is a very simple one. It's called full house, in reference to a house in this terminology. A house is either a row, a column, or a subsquare. And the rule of the game is that for each house, you have to use the 9 different numbers. So here, it's obvious that it can only be a 6, because this is the only number left over there, and it can only go here. Some heuristic and strategy are slightly more involved, and the one which is called hidden single is slightly more complicated, but it's still pretty simple. And this one tells you that in these cells, it can only be a 6. Why is that? Because we cannot have a 6 here because of this one over there. We cannot have a 6 here because this column over there. And because of this one here, it tells you that in this row, there must be a 6. So there cannot be a 6 here. So the only place a 6 can fit is here, et cetera, et cetera. So you have nice strategy. You have the butterfly strategies, the wing strategies. And you have the last resort strategy, which is something very hairy as this one. So what did we do with this thing? We implemented a Sudoku solver in the HipHop programming language, which takes 2 inputs, a puzzle, and a set of strategy you are allowed to use to solve your puzzle. So this is pretty straightforward, how we did the thing, but just for being sure that we are aligned and we have the same understanding, I will just show you an execution of our program. So we start with a puzzle, and imagine, for the purpose of the talk, that we can only use hidden single as a strategy and guessing. So we start with hidden single, we discover the number 6, and now we are stuck, so we guess. So we pick a cell and we pick a number for that cell, the 4 over there, and we do it again. So we explore with hidden single, we discover a new number, we are stuck again, we guess again, and oops, we are stuck because we have an inconsistency, so we have to reject this branch. So we roll back and we go into another direction. Pretty straightforward, regular search. So what is at stake here? What are we doing here? Well, we are dealing with state, because obviously the puzzle or the state of the puzzle is something we have to deal with in our program. We are dealing with parallelism, because when you run heuristic, you run them in parallel because they collaborate one with each other. And we deal with abortion, because if we are done with a puzzle or we detect a rejection, we have to roll back and give up everything. The promise of HipHop is exactly to give you state parallelism, abortion, and determinism, and composition. You may have several instantiations of HipHop, but still it's a composition of functional programming and imperative programming. The previous version of HipHop was based on the scheme programming language, but because we are interested in web programming these days, HipHop is a mashup of JavaScript and Esterel. So now, for the rest of the talk, let me dig into a little bit of HipHop, and I will show you what HipHop programming looks like. So HipHop is a combination of Esterel and JavaScript, so it's a mashup, if you want, of Esterel and JavaScript. And actually, HipHop is a DSL embedded inside JavaScript. So here we have a HipHop program, and here we have the JavaScript program that is driving this program. For the rest of the talk, I will be using a very simple application, which is a simulation of a traffic light, and here is my traffic light over there. So the HipHop program is composed of modules, and you see one module here, that are to be loaded into a reactive machine. And the way you will execute HipHop is by making the machine a step, or what we call a reaction. And these reactions are controlled by JavaScript. So the HipHop program here is using threads. In this first version, we just have one single thread, but the idea is that we will run plenty of threads, and they will communicate with signal broadcast. And here we have the declaration of a signal, the light signal. It's an input and output signal, meaning that JavaScript will be aware when we trigger this signal, and we can attach a callback to this signal over there. It has a default value, that is, if you do not emit the signal, it has this value, which is an empty set. If you happen, during a reaction, to be emitting several times the same signal, then all the values will be accumulated using a function you declare here, and this function has to be associative and cumulative. Now, for the rest of the program, it's just an infinite loop that runs this thing forever. It emits the signal red, and it yields. Yield means give back the processor to JavaScript. And a reaction ends when all the threads that are running in the machine yield the processor back to JavaScript. So let me run this program by just clicking this React button over there. I have red, 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 etc. for each reaction. OK? Pretty simple so far. So let me focus just on the HipHop part, and let's forget about JavaScript for the rest of the talk. HipHop is a very small language built on a very tiny core, and we elaborate a true language by just adding some syntax, as we would say in Scheme, which are just a bunch of macros. So actually, we are just giving names to common patterns in the language. And this pattern here that you see, this loop forever, we give it a nice name. We call it sustain. When we are sustaining, we are just running forever something that emits a signal. So now, if we want to have our traffic light stopping being red at some point, something maybe we want, the normal way with a programming language would be to run something like a for loop, where you would say for e equals 0 to 10, do something, and then do something else. This is not the way of reasoning in HipHop. In HipHop, what you would do is that you will run another thread that will be controlling the first one. So here, with this fork construct, we are creating two threads. One here, which is sustaining red forever, and the second one that will say, for the first reaction, I give back the processor. For the second reaction, I give back the processor. And for the third reaction, I break, meaning that I stop all this thing and jump to this label immediately. Let me run this program. First reaction, second reaction, third reaction, and now I break, so no more red. This is the normal way of programming with HipHop. So now you see we have two threads on this program. At some point, after red, we would like our traffic light to be green. So let's do that. Let's modify the program for having a green light. OK, pretty simple. In sequence, when we are done with red, we sustain green. Let me run my program. I have red, red, oops, red and green. So what's going on here? The problem is that at the same reaction, we have emitted a red value, and also, as soon as we have stopped the execution because of the break, we have the green value. So we have the two values happening at the same moment. If we want to solve this problem, we need a new construct that will suspend the execution of emitting a red during the reaction. So let me modify the program. I introduce a local signal, which is S here, that I will emit just before breaking. And here my sustain is embedded inside a suspend form that says that immediately, if S is emitted, suspend your computation, that is, stop your computation. And the beauty of Esterel and HipHop is that no matter in which order you execute the thread, as soon as you have an S emission, the semantics tells you that you have to stop your execution right away. No, purely deterministic and purely formally defined. Good. So now you know almost everything about core HipHop, that is the essential element of HipHop. Let me dig a little bit deeper into the collaboration in between HipHop and JavaScript. The only thing, or the main thing we saw so far, is that it's JavaScript that controls when HipHop reacts. That is, each time I click on my web page, I say react. Now, let's do something else. Actually, it turns out that a HipHop program is a JavaScript value, and we are just constructing HipHop programs by just building JavaScript function and executing them, returning a value which is a JavaScript program, which is a HipHop program. And inside this syntax, we may use, we are actually using just placeholder where we inject values, and this is what we are doing here. We are building a JavaScript constructor that returns the same program as before, except that the signal we want to trigger is a parameter of the JavaScript function, and the numbers of time we want to yield is also an extra parameter of the JavaScript function. So now I'm able to dynamically build HipHop program. So let me play with that. Now, instead of having just red, I will have a true traffic light with red, red, green, orange, red, red, green, orange, red, red. OK, you get it? So now, just keep in mind that we have 2 threads per phase. So it means that in this program, we are running 6 threads in parallel. And we can do something even nicer, because now we are able to build a traffic light. So we are able to build 2 traffic lights, one for north-south, and one for east-west. So let me run this program. Beautiful, isn't it? My 2 traffic lights are purely synchronized. So maybe you can ask yourself, OK, but what about the math here? How did I get the math correct? Is the math correct? So you have 2 ways to solve this problem. First one is HipHop is compiled down to logical formulas. So you can just translate that into a format suitable for your SMT solver and ask the SMT solver, is it possible that one of the traffic lights is not red? Or you can do something else, which is something we use extensively in the puzzle solution. You can build an observer that is another thread that is running on parallel, and that is just checking to what is happening. And this observer is just telling you that if it happens that we don't have at least one signal which is red, we trigger an alarm and we switch off everything. And once again, because of the deterministic semantic of HipHop, you are guaranteed that if it happens that you have a traffic light which is not red, this piece of code will be executed. OK, so now I'm almost done. I hope you are convinced that there is something interesting with HipHop. But you know, clearly, we are adult, and we know that there is no such thing as a free lunch. So maybe there is a catch somewhere with this immediacy of signal triggered. And the catch is actually logics eat bags with this story. And what it means is that you may be tempted to implement paradox. And this is the implementation of the liar paradox, which is this sentence is false. And if I translate this program, I say, if in the reaction this signal has not been emitted, emit it. This is an inconsistency, and this is incoherent. If I add a yield expression here, that would be fine. But if I don't, this program has to be rejected because it is not deterministic. You cannot resolve it with the semantics. And you have variation of that program, which is the second one. If this signal is present, emit it. This is also an incorrect program because you have 2 possible interpretations. Either you emit the signal or you don't. So this is rejected. And in the end, you have the composition of the 2. If the signal is present, emit it, else emit it. This is also incorrect. So it takes a little while to get accustomed to these kind of things, but we have tools for detecting this error, and in the end, you can manage. So I'm almost done. The thing you have to, maybe you feel a little bit frustrated because so far I have not been talking so much about Sudoku, but consider this talk just as a teaser for you to read the paper, because the paper contains the full implementation of the Sudoku solver. Everything is there. And in addition to the paper, we have also prepared an artifact for you to play with the solution, and we have even some assignments for you to have even more fun with the artifact. And maybe last things, as you may have understood, all these slides are implemented in HipHop, so if you are curious to see how they are implemented, you may check this GitHub page where you will find the whole implementation of the website. Maybe last word, as you have understood, we love functional programming, but we also love functional programming and imperative programming. Thank you so much.
Any questions? That's a new one.
I have been too intimidating. You know.
So then I have a question, I guess. So can you hint at sort of the multiplication that you get from combining this with functional programming?
Say that again.
So your abstract says you're multiplying the power of Esterel, which is what you just introduced, right, with functional programming.
Yeah.
So we learned about the Esterel part. What's cool about that? Is there something specific you get from the combination of the two?
Yeah, okay. So sorry, I not got it. Yeah, absolutely. Sudoku solver, it's not possible to write it in plain Esterel because you need a memory for exploring a direction and backtracking. And this is something we get from functional programming. That is, it's really the idea of the functional programming controlling the reactions and observing the result of the reaction and going into one direction or the other that is used to implement this kind of thing. So we use the functional part for the memory of the execution, if you want.
Okay.
So yeah, it's essential to have the composition.
Well, thank you. Thank you, Manuel, again. There is a question. I'm sorry. Wait, we have 1 more minute, and there's one more question.
Okay. Thank you. So I got the vibe of an actor system when I was seeing the HipHop code. Was there an inspiration of from actor system for your HipHop?
Yeah. So what is the question?
So the question is, did you find any inspiration from actor systems in your HipHop?
It's the other way around. It works. We have several applications that have been already implemented in HipHop. One is a music composer that is building interactive classical music, and all his core are just HipHop program where he interacts with the audience for detecting in which direction the music is supposed to be going. And we have played real concert in real concert festival with HipHop running on this machine.
Okay, thank you.
You're welcome.